Hi guys, this is a quick follow-up tutorial to the tutorial on how to perform a test for differences between two related groups, in which I'm just really quickly going to show you how you create graphs for those tests. Now, the two tests for differences for related groups are the paired samples t-test, which uses means and standard error to compare the measurements of two related groups, and the Wilcoxon signed rank test, which uses median and ranks. Now, for those, we would produce a bar chart in the case of the parametric t-test and a box plot in case of the Wilcoxon test, because those show the kind of measurements, central tendency and dispersion which were used by the test to make the comparison. Now, with related samples, this works slightly different to independent samples, so I'm just quickly going to talk you through it. So if you have performed a paired t-test in order to compare differences between two groups, and if you want to know more about these data sets, then I'd recommend that you look at our tutorial on the actual tests for differences between two related samples, which is on the same channel. Now, if you want to create a graph after you've performed a paired samples t-test, you would go as normal through the graphs and then chart builder function, which always asks you whether you are sure that you've set up your variables correctly, which in this case we have, so we click OK. And then this pop-up window shows up, and this is what we always do when we want to create any charts in SPSS. In this case, because we've used means and standard errors, because we've performed a t-test, we will create a bar chart with standard error bars, and in order to do that, we click on this simple bar chart and we drag it across into the preview window. And then the only difference between related samples and independent samples in this case is that we don't actually have a variable that usually goes on the x-axis. We have two versions of the same measurement. One of them is before, one of them is after, because we have paired samples. So both of those actually have to be placed onto the y-axis in order to create a bar chart. Okay, if you do that, it'll come up with this quick window here, which just says, are you sure that you're going to want to use these two values as a y on the y-axis, and that you want to use the labels, basically what you've set in the variable view as label, to be the names of the two bars at the bottom, which is what we want. So we click OK, and then that's what it's going to create. So what it's done now is it's basically created two bars, one for reaction time after coffee, one for reaction time before coffee, just like we would want it. Okay. The last thing we now need to do is add the error bars to this, because we should always show the dispersion as well as the central tendency of our data, and that is done in the element properties over here. We need to make sure that bar 1 is selected up here, because that's what we want to edit the properties of, and on those bars we want to add error bars. So we just tick this box, and because the t-test uses the standard error of the mean, that's what we want to display as an error bar. The default is set to a multiplier of 2, which I don't understand why, but we always want to show one standard error of the mean and not 2. So we change the multiplier here to 1, and that essentially is everything we need to do. We can just click OK, and then the graph will appear in our output window. This is what we want. The only thing that might be good to do is to actually change this to what the measure is. We don't usually have titles in our graphs, and we want to give the x-axis a proper label as well. Now, in order to do that, we can double click on this graph, and then we get the chart editor open. In order to change, for example, the y-axis label, we select it once, and then if you click on it again, don't double click because that doesn't work, but select it, then click on it again in order to be able to change this. Now that would be reaction time in seconds. And then in your figure caption, you would normally specify that this is the mean and standard error. Okay, that doesn't need to be on the axis. And then we want to add an axis down here. First of all, we can get rid of this title simply by, again, selecting it and then just deleting whatever's in here. And then we would like to add an x-axis label. So if we just select the x here, which is everything to do with the x-axis, and we go to labels and ticks, we can then actually say we want to display an axis title we click apply, and it appears down here. We can close this now, and then just like we changed what was on the y-axis label before, we can change this now to caffeine status, for example, because that's what this represents. This is before and after. Technically, if we wanted to, we could also change these to this one is after and this one's before, and so on. So there are all sorts of things that you can do in this chart editor, but for now this is all we need. That is our graph done. If we close this window, then whatever we've changed here appears in our output window. Now I'm going to go back to the data, because what happens when you've created a Wilcoxon signed rank test, because your data have been non-normally distributed, then the bar chart with standard error bars is not the appropriate graph to use, because it shows means and standard errors, and that's not what the test actually used in order to compare the differences. Wilcoxon uses ranks, and the median and interquartile range is a better way to represent these ranks if you are going to create a graph. Now, the only issue is with box plots, which is the correct graph to use in that case. When you have paired samples, you can't create them in the graph chart builder. I can show you this quickly. So if we go back through the same pathway as before into the chart builder, and we now actually select the box plot here, we can't, unfortunately, move both of these onto the y-axis. It just doesn't allow you to do it. What it will do is it will replace one with the other every time, but it won't add them both. So this isn't actually how the box plot is created for paired samples. The only way to make that kind of graph is to go through Analyze, Descriptive Statistics, and then Explore, just like we go through when we actually do our normality test in the first place. And just like in that case, we move both of these measurements into the dependent list. And then when we go into plots, we can select here a box plot that lets us group the dependents together. I'm going to deselect everything else because all I want at this time is the box plot. And then when I click OK, it will create just that for me. And just like in the other graph that I created a minute ago, you can now actually double click this. We need a y-axis label. Okay, and then we can change that to what it actually shows later on. We also need an x-axis label, which I'm going to get just like I did before. Okay. And then we can essentially just manipulate those exactly the same way as we did before. So this here is caffeine status. And this here is reaction time in seconds. Always make sure you give the unit as well in your axis label. And now this time it's actually done it before and then after. So it's switched them around. That's before, and this is after. Okay, and now we have our graph that would be appropriate if we had run a Wilcoxon signed rank test in order to look for differences between these reaction times in students or people before and after they've had caffeine. Now this whole thing works slightly differently when you have independent samples, so I'd recommend that you watch the tutorial on how to create graphs for independent samples as well.